Hello. This is example 2 in chapter 2, section 7. Here we're going to introduce how to horizontally change parent functions. Now, horizontal, what you should remember is that horizontal is always kind of left to right. Think of the horizon being left to right as you look out towards the horizon. Now, if you have a function, any function, just call it y, and it can be any function of x. What I want to do is I want to think of how do I take this function and change it. Well, there are two possibilities. I can have some number in front and multiply by the x, or I can add or subtract from the x as well. Now notice that everything that I've done here has happened inside the parentheses. That's really how you can tell if you have horizontal changes to parent functions or to any function that you've been given, honestly. Really, we're going to be working with just parent functions, and I just kind of want to illustrate this. If I have the function y equals x squared, I want to look at what the h does. The h is a translation. That's what we call a translation. The a, it's either a stretch or a shrink depending on what a is. Now, one thing I want you to remember is that when it's inside the parentheses, you do the opposite of what it says. Okay, so for example, it's saying a times something. So really, what we would really do is divide by it. And here, this is saying subtracting h, so I should really add h. Or if I had an addition here, or in other words, if it was plus h here, that would be saying add h, so I should actually subtract h. Let me show you what I mean here. It's actually easiest just by seeing an example. What I want to do is I want to convert y equals x squared into y equals x minus 3 squared. To do that, I want to first start out with the parent functions table. In other words, my xy table for y equals x squared. And yes, I am going to require you to do your tables on your tests, so you might as well get used to it now. So again, y equals x squared is negative 3, negative 2, negative 1, 0, 1, 2, and 3. And your y values are 9, 4, 1, 0, 1, 4, and 9. Now I want to convert y equals x squared into y equals x minus 3 squared. Effectively, what you should see is that this was the x originally. So all of this became x minus 3. Notice how this x became something right here. That's what's happening here. That's how you can tell it's a horizontal translation or horizontal stretch, if it's inside of a parentheses effectively. So what we should do is, since it says minus 3, what I really want to do is I want to add 3. And since it's inside with the x, it affects the x coordinate. So if it's inside of parentheses, it affects the x coordinate. And we always do the opposite of what it says. So this says subtract 3. So what I really want to do is I want to add 3 to the x value. So this table becomes a new table, a new xy table. Except this time, the x's will change. The y's will actually stay the same though, because we're only changing the x value. So the y's will all still be 9, 4, 1, 0, 1, 4, and 9. But all I have to do now is add 3 to all these x's. So negative 3 plus 3 is 0. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2, and so on and so forth. And I have just converted y equals x squared into y equals x minus 3 squared. At this point, I can graph my resulting function. So I graph 0, 9, and there are 10 of these hash marks, so 9 goes right there, so that's 0, 9. 1, 4, 1, 1, 2, 3, 4. 2, 1. 3, 0. 4, 1. 5, 4. 6, 9. And you can see the parabola here. Notice this is the horizontally translated to the right parent function, or translated function. Let me go ahead and graph the parent function so you can see what happened. This is y equals x squared, so negative 3, positive 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Go ahead and graph this. Sorry, I'm not too used to drawing on here. But what you should see is that this original parent function was moved 3 units to the right. Another thing you should notice is that this translation actually changed. This is called the vertex. It actually changed the location of the vertex. If there was a number in front, if I had, say, 3 times all that, that 3 would not have actually changed the location of this, but it would have changed the location of the y values here. Or, sorry, the x values, not the y values, because it's inside the parentheses. Alrighty, that is it. Let me put all that back there.